Alright, doing the cumulative interest payments, we have the rate, which you select D18 and divide by 12, it gives you the monthly rate. The number of periods total, your D20 times 12 to get 360. Your loan amount for 900,000, select D17. Start period 1, end period 12. And the cumulative interest paid between the two periods, 49,197. And go ahead, put that value in. We're going to turn that into a monetary value. And I'm just going to go ahead, take all these cells and make them absolute. By doing that, I'll drag the formula over, and then I'll just switch the beginning and ending dates or times. Now, I was talking before about the 0, 1. 0 is for at the end of the month payments, 1 is for at the beginning of the month payments, and what we have here is end of the month payments, so I'm using 0 versus the 1. I know in the last video I mentioned beginning of the month. A lot of times you're going to pay at the end of the month your mortgage, so I decided to go with 0 at the end of the day. 24 is the next period, 13 to 24 for year 2, and 25 to 36 for year 3. And one way to know that you're doing it right, your interest should be going down, because as it works, an annuity is, or excuse me, an amortized loan is paying less principal in the beginning and more interest, and slowly you start paying more principal and less interest, but you're still paying that same amount every year typically, except for maybe the last year of the loan and that last payment of the loan. Otherwise, it's always going to be that 61,321.21 cents value that you're paying each year on the loan, and $5,110.10 a month paid on the loan. Finding the depreciation, we have looking here, the depreciable base divided by the cost recovery period. And it's a relatively simple equation, straight line, so just take these two values, make them absolute, drag that value over to the other two cells, and voila, it'll be the same in each one. That depreciable base, that depreciation, you take the depreciable base, divide it by that. That's how much you can subtract each year and depreciate the house. Now, the taxable income is going to be the net operating income plus the reserves, plus we're going to add the interest because the interest value is negative, and we're going to subtract the depreciation value because it's positive. If you want, you can even make the depreciation value negative up here and then do a sum. It's an option for you. Just go ahead, check out, make sure everything seems to check out. And it looks here as if everything is pretty solid. One thing that's a little bit questionable, you can see here that the interest is, or the taxable income is actually negative, which basically is going to mean that you're not really going to be able to tax them at all. They're not going to have any sort of income that they're going to be taxed on. And as a result, I'm going to take that into account in the tax impact section. using a special little formula. Now that doesn't typically happen a lot necessarily. It really depends on the problem, but it can happen. So I'm going to show you how to take care of it. So let's do this. The tax impact is typically a simple enough equation of the taxable income times the investor's tax rate on income, and make that value absolute, and there you go. That's the tax impact. Now, depending on if you can expect a refund of some sort or not, you may or may not be able to just leave this negative. If you wanted to go and take that into account, oh, I don't have the option to make it negative, then you can do an if statement. Now, if, for example, this cell is greater than 0, then B51 times D24 is the answer. If false, then put in 0. And it'll just give us a 0 value. I'm going to just drag this over. I'm going to show you what happened. Now, because these values were not less than 0, you can see C51 is greater than 0, so it put in C51 times D24. And same for this one. Because you're really not going to have a tax impact that's giving you money back necessarily if you have a negative taxable income. It just doesn't typically work that way. So if we take this value and subtract the tax impact, the before tax cash flow minus the tax impact, we get the value to put in there. And voila, you have your after-tax cash flow. Now, future sales price. Working here, we have the acquisition price multiplied times 1 plus, now remember this is a quantity, you want to make sure that you're using that fact, and there's going to be an appreciation, and that's the total for the holding period in this case, so that 10% value right here, and just hit enter. You can turn that into a monetary value and get that future sales price less the selling costs equals this value here times 6%. Net proceeds from sale equals future sales price minus selling costs and less loan balance. Alright, now you see the loan balance is done here. I'll walk you through the steps. You find the loan balance by using the present value equals PV parenthesis D18, which is your loan well here, if you click on it, you can see the loan rate. It's your loan rate divided by 12. Number of periods, D20 times 12 minus 36, because you've had 3 years. So 3 years times 12 is 36. If you were going to do this for a number of years beyond 3 or less than 3, Then you adjust this number of periods. If you did it part of the way through the year, again, adjust that number of periods 36 value for it. That's one thing you'll have to do manually. Of course, this is set up for selling after 3 years. If you're going to go further, less, you have to go and take that into consideration. Something to consider in this when you're doing this problem, if you ever do it in real life application for something beyond 3 years or less than. Not to drill it into the ground or anything, but it is an important thing to consider. Payment, you have the 5,110.10, how much you're spending, that's the negative value. Your future value is going to be 0, type 0, just keep that consistent. I see it as important if you're going to go and have the interest payments as being taken from a mortgage being paid at the end of the month. You might as well do the same for the present value of the loan. Now, gives us the present value of the loan, giving us the before tax equity reversion. In other words, this 1,240,800 value minus the less loan balance. So, before tax equity aversion. In other words, this is how much you're going to get from your equity before taxes. And it's not including the present value of funds, stuff like that. That's also important to keep to take into consideration. So, net proceeds from sale equals this value here. The original basis, we're going to take that as the acquisition price. So, set it equal to the acquisition price. And the depreciation taken equals the sum of the depreciations. Now include the improvement expenditures. Cost of improvements made at the time of purchase, $25,000. Now it's important to make a note that it's made at the time of purchase. That might not seem like a big deal, but it really is. So we have that set equal to that. So I've got $25,000 amount. The adjusted basis equals the original basis minus the depreciation plus the improvements, giving us our adjusted basis. Now, next step is the capital gain value, which is simply the net proceeds from the sale minus the adjusted basis. Easy enough. Depreciation portion taken is equal to the depreciation portion multiplied times, or excuse me, that value there, and then equals depreciation times 25%. Now, this is the depreciation taken. To find the appreciation portion, it equals capital gain minus the depreciation. The tax equals the gain times the appreciation portion capital gain tax, getting you your 2,370 and 27,818. Now, with that done, you are set to get your initial investment that you put in, which is in fact easy enough. That would be your loan to value, your acquisition price